Hello, today we'll be covering the Mount Pinatubo eruption. This is a case study by Gillian McCarthy. Today we'll be learning about volcanoes, how they work, and the aftermath left behind by them before moving on to the Mount Pinatubo eruption and then the lasting effects of that eruption in 1991. We'll begin with volcanoes. What are they and how do they work? So what are volcanoes? Volcanoes are openings in the earth that allow molten rock, known as magma, gas, and debris to escape to the surface of the planet. Volcanoes are architects responsible for terraforming over 80% of the Earth's surface. They've caused the deaths of millions of animals and people over the centuries and are a significant contributor to the rise in greenhouse gases in the atmosphere. In fact, a volcanic eruption typically causes global cooling, which lasts for a couple of years after the eruption. Volcanoes destroy landscapes, but they also renew them. Soil that is recovered after a volcanic eruption is incredibly fertile, much more so than soil which is not recently recovered from a volcanic eruption. There are several parts to any volcano, and we'll be going over these parts over the next couple of slides. The parts we'll be reviewing include ash clouds, ash fall, craters, layers, main and secondary vents, lava flow, pyroclastic flow, lahar, secondary cones, and magma chambers. Ash clouds are a combination of rock, tiny particles of supercooled lava known as volcanic glass, and other minerals. The particles are usually smaller than an inch in diameter, but can contain powdered rocks from the volcano's exterior shattered during an eruption. Ash fall is the layer of ash which falls down to cover the earth rather than hanging out in the atmosphere. Ash is ejected from the volcano's main vent and typically does not directly cause any casualties, though many accidents do occur due to low visibility and poor traction caused by it. The main vent is the main outlet for the magma to escape. Under pressure, the magma in the chamber can rise up the main vent, which is the central tube through the volcano. Secondary vents are smaller outlets through which magma escapes. Craters are the steep-sided walls made of hardened lava that surround the main vent. Layers of ash and cooled lava are typical of composite volcanoes. Pyroclastic flows are avalanches containing hot volcanic gases, ash, and rock. They are the most deadly event to happen at a volcano. Also known as a parasitic cone, secondary cones build up around secondary vents that reach the surface on larger volcanoes. Lava flows are streams of molten rock that pour or ooze from an erupting volcano. Lahars are mud flows created when water, typically from rain but sometimes from melting glaciers or other sources, and volcanic ash mix. When lahars settle, they can be meters thick and as hard as cement. They can also occur long after a volcanic eruption. A magma chamber is a large pool of liquid rock beneath the surface of the earth. The molten rock, or magma, in such a chamber is under great pressure. Given enough time, that pressure can gradually fracture the rock around it, creating a way for the magma to move upward. Here are all of the different parts of a volcano that we went over. Again, these parts include ash clouds, ash fall, craters, layers, main and secondary vents, lava flow, pyroclastic flow, lahar, secondary cones, and magma chambers. Next, we'll go over how volcanoes work and what causes eruptions to occur. First, all volcanoes contain a magma chamber, which forms in areas where the mantle's melting point has been lowered, typically due to the interference of water. The resulting magma typically remains under the Earth's surface due to a delicate balance between the Earth's crust pushing down on the magma and the magma pushing back up on the crust. When this balance is disrupted, an eruption occurs. There are a few things that can cause this balance to be disrupted. One of the most common is an overbalance of the magma's force upon the crust. Magma contains various elements and compounds, many of which are dissolved in the molten rock. At high enough concentrations, compounds like water or sulfur no longer dissolve and instead form high-pressure gas bubbles, which decrease the density of the magma. When these bubbles reach the surface, they can burst with the force of a gunshot, and when millions of bubbles explode simultaneously, the energy can send plumes of ash into the stratosphere. Sometimes eruptions are caused by a decrease in the force exerted by the crust. Landslides can remove massive quantities of rock from atop a magma chamber, dropping the force exerted and instantly triggering an eruption. This process is known as unloading, and it's been responsible for numerous eruptions, including the sudden explosion of Mount St. Helens in 1980. Unloading can happen over long periods of time as well, due to erosion or melting glaciers. Corrosion can also lead to volcanic eruptions. Acidic gases and heat escaping from magma can overload rock through a process called hydrothermal alteration, which gradually turns hard stone into soft clay. The crust could also be weakened by tectonic activity. Earthquakes can create fissures, allowing magma to escape to the surface, and the Earth's crust can be stretched thin as continental plates shift away from each other. Here's a picture of a volcano mid-eruption. Next, we'll cover the aftermath of a volcanic eruption. Exposure to ash can be pretty harmful. Infants, elderly people, and people with respiratory conditions such as asthma could have serious problems if they breathe in volcanic ash. Ash is gritty, abrasive, and sometimes even corrosive. Small ash particles can scratch the front of the eye, leading to eye injuries and even blindness. Ash from volcanoes can also contaminate water, coat highways, cover yards, and ground airplanes. After an eruption, roofs on buildings may collapse and kill people if enough volcanic ash particles land on them. Most gases from a volcano quickly blow away. However, heavy gases such as carbon dioxide and hydrogen sulfide can collect in low-lying areas. The most common volcanic gas is water vapor, followed by carbon dioxide and sulfur dioxide. Sulfur dioxide can cause breathing problems in both healthy people and people with asthma and other respiratory problems. Other volcanic gases include hydrogen chloride, carbon monoxide, and hydrogen fluoride. At low levels, gases can irritate the eyes, nose, and throat. At higher levels, gases can cause rapid breathing, headache, dizziness, swelling and spasm of the throat, and even suffocation. These gases also block up the atmosphere, typically causing a 1 to 2 year global cooling effect over the Earth. Serious problems may occur when fires start as a result of contact with hot lava. Flowing lava can kill people, animals, and plants that lie in its path. For example, the Mount St. Helens eruption of 1980 killed about 24,000 animals. As plants and animals die, famine can arrive in areas where people rely on these food supplies. Volcanoes can also cause landslides, tsunamis, wildfires, floods, mudslides, and power outages. Powerful volcanoes, such as Krakatoa, can cause catastrophic damage due simply to shock waves. Exploding with the power of 13,000 nuclear bombs in 1883, Krakatoa destroyed entire villages and killed over 36,000 people. The shock wave was so powerful that it destroyed most of the island, and instruments detected the blast thousands of miles away. Here's a small example of the aftermath of a volcanic eruption. Next, we'll look at the Mount Pinatubo eruption. Here's a picture of what remains of the volcano today. Mount Pinatubo is located in the Luzon Island in the Philippines, located off the coast of Southeast Asia. Here are a couple of references to better understand the exact location. Now, the official eruption took place on June 12, 1991. However, there was a bit of a buildup beforehand. In June, a magnitude of 7.8 earthquake hit the island of Luzon about 60 miles away from Mount Pinatubo. At first, only a landslide, a few minor earthquakes, and small steam eruptions were detected in the area around the volcano. Soon, however, magma started to escape to the Earth's surface, with more earthquakes, steam explosions, and ash clouds joining. Still, the volcano hadn't officially erupted yet. On the 12th, it finally did, causing the second highest shock wave of all time. Following the eruption, thousands of roofs collapsed under the weight of ash made wet by heavy rains. Ash deposits from the eruption were also remobilized by monsoon and typhoon rains to form giant mudflows of volcanic materials known as lahars, which we covered earlier and which caused even more destruction than the eruption itself. Huge avalanches of searing hot ash, gas, known as pyroclastic flows, which we covered earlier, roared down the flanks of Mount Pinatubo, filling once steep valleys with fresh volcanic deposits as much as 660 feet thick. The eruption removed so much magma and rock from below the volcano that the summit collapsed to form a large volcanic depression 1.6 miles across. Here's a photo comparison of the volcano during and after the eruption, which showcases the new crater where most of the volcano used to be. Much weaker but still significant eruptions of ash occurred occasionally through early September 1991. Thankfully, scientists from the Philippine Institute of Volcanology and Seismology and the U.S. Geological Survey had forecast Pinatubo's 1991 eruption, resulting in the saving of at least 5,000 lives. Commercial aircraft were also warned about the hazard of the ash cloud from the June 15 eruption, and most managed to avoid it. However, over 800 people did die during the eruption. Lastly, we'll speak about the lasting effects of volcanic eruptions in relation to the Mount Pinatubo eruption. The thick, valley-filling pyroclastic flow deposits from the eruption insulated themselves and have kept much of their heat. These deposits still had temperatures as high as 900 degrees Fahrenheit in 1996 and may retain heat for decades. When water from streams or underground seepage comes in contact with these deposits, they explode and spread fine ash downwind. Since the eruption, ash deposits have also been remobilized by monsoon and typhoon rains to form giant mudflows of volcanic materials, aka lahars. Nearly 20 million tons of sulfur dioxide was injected into the stratosphere in Pinatubo's 1991 eruption, and dispersal of this gas cloud around the world caused global temperatures to drop temporarily by about 1 degree Fahrenheit. The eruptions have dramatically changed the face of central Luzon, home to about 3 million people. About 200,000 people who evacuated from the lowlands surrounding Pinatubo before and during the eruptions have returned home, but face continuing threats from lahars that have already buried numerous towns and villages. Rice paddies and sugarcane fields that have not been buried by lahars have recovered. Those buried by lahars will be out of use for years to come. Congratulations, you've reached the end of this presentation. I hope this was as informative and pleasant for you as it was for me. If you don't mind, here's a list of all the sources I got from my information from, as well as the various pictures which were used throughout this presentation. And that's the end of them. Again, thank you so much for watching. I hope you enjoyed this presentation on the Mount Pinatubo eruption. Have a